Hello everybody, I am Arda. Today I am going to talk about our project, which is called Counter-Crowded. As we all know, COVID-19 pandemic, also known as coronavirus pandemic, is ongoing global. That's why in 2020, many countries around the world created and enforced heavy restrictions geared towards reducing the spread of the coronavirus. Most important one of these restrictions is a limitation of number of people in the closed spaces. But this limitation is hard to follow in some cases. In this kind of circumstances, counter-crowded provides a more convenient way for the obeying the limitation on number of people in the closed spaces. Before go deeper, let me introduce the topics will be covered in this presentation. My talk will be in two parts. In the first part, we will look at the problem that we tried to solve with our project. Then in the second part, we will analyze our solution. And I divided solution part into three subparts. In first subpart, we will look at counter-crowded setup. Then we will look at how it works. And in the last slide, we will see the implementation of our project. Let's begin with the problem we want to solve. Actually, the problem is based on social distancing rules, and this rule should be obeyed wherever you are. That's why government set some limitations on number of people in the closed areas. Source of our problem is this limitation. How can we count the number of people inside the area? Or how can we warn the people when the number of people in the area is out of limit? Our project Counter-Crowded provides meaningful answer for these questions. But first we need to set up components of the project to get meaningful answer. Counter-Crowded consists of 9 parts. In the first part we have Arduino Uno, includes code block of our project. And we have ultrasonic distance sensor that emits the sound waves as input. We have LCD screen for displaying output. We have breadboard that is used for the connect components. We have a battery for energy source. We have RGB lamps for the visual interaction. We have buzzer for auditory interaction. We have resistance and jumper wires, a connection between input device and output devices. When all components come together, it will look like this. These ultrasonic distance sensors emits the sound waves as input and send that input to the Arduino. Arduino process that input and send that output to the LCD screen and these RGB lamps and the buzzer. Now let's consider how these components theoretically works in the upcoming 3 slides. As you can see in this photo, these 2 sensors emit the sound waves periodically from the front side and the back side of the door. When there is an activity in front of these sensors, Arduino takes this activity as entry or exit. And Arduino gets these activities as input and shows the output to the output in the LCD screen. But what happens when someone enters the place? Let me explain in the next slide. When someone enters the area, Arduino detects the mobility under the door and to process that input and then send that output as entering message in the LCD screen. Also, it increments the quota by 1 in the LCD screen. And also, counter-crowded have additional features that provides control mechanism to prevent simultaneous entrance. When entry is detected, exit LED turns red and entrance LED turns yellow. These mechanisms specifies that the people want to enter that place should wait until LEDs turn green, until LED turns green. But what happens when the person wants to leave? I will show it in the next slide. When someone leaves the place, the process actually same as the person entered the place. Arduino detects the mobility under the door and process that input and then send that output to the LCD screen as leaving message. Also decrement quota by 1. Besides these entry and exit processes, most important feature of counter-crowded is providing sound for exceeding number in the people in the place. How it works, let me show in the next slide. When the limit is reached, LED turns red and LCD screen displays full capacity message. After that, buzzer will beep. That's why people wants to enter that place knows that place is over capacity. After the place reach full capacity, if someone try to enter, buzzer will beep again. These 3 slides was the theoretical description of our project. Let's look at the implementation of our project in the next slide. For some reason, video is not working properly in this slide. I'm going to open it the outside of the slideshow. First, I need to say we defined the capacity as 4, and these 2 LEDs provides a control mechanism to prevent simultaneous entry and exit. Let's see in the action. As you can see, there the LEDs turned red and yellow. This means you should wait until the actions in the LCD screen should be completed. As you can see, entering message is displayed in the LCD screen. And increment the quota Y1. When the last person enters that place, buzzer will beep because the place will reach defined capacity, and also LCD screen will display full capacity message. My friend who holds the camera, this guy, is gonna try to enter, and buzzer will beep again because the place is reached defined capacity. When someone tries to leave, same process will happen again. LCD screen displays a leaving message and decrement the quota by 1. As you can see, displayed the leaving message and decrement the quota by 1. This was end of our implementation video, and also that brings us to end of the presentation. I would like to summarize by saying what I have done so far. I tried to explain what is the source of the problem. Then I explained the solution we created. After all of this, we watched the implementation of the solution. Thank you so much for your attention and interest. If you have any question, you can ask in the comment part below.